how consumers are being attacked. The permission model that's used in Android is somewhat a new model, giving the whole decision-making process to the consumer, which has its pros and cons. I mean, the difference is consumers aren't security professionals, so you really have to polish that information before you pass it off to them, which is some of the things we'll talk about during the presentation. Big thing here, the app's not adequately reviewed before being prior published. And a lot of different variances here, but basically anybody can create an app. They spend, the current price is $25, $50. You buy a publishing license, you can push an app out. You can create it whatever you want from any company. There's no validation process at all. A little bit of malware scanning happens from what I've been hearing, but it's minor, looking for the basic virus classes, or malware classes rather in this case. The Android marketplace, the biggest where is site in the world currently, besides third-party markets, which we'll talk about as being a much bigger threat here. So one of my biggest pet peeves is how the permissions are displayed. For example, the read phone state permission. When you consumers see this, they see allows read access or read-only access to phone state. It's not descriptive. For us here, we have an idea, and we learn and we read about it, and we know what to accept. But for consumers, for our level and scale, for other people, they have no idea. They have no idea. Like, for example, maybe we should say we can read your cell phone's ESN, your phone number, the SIM card serial, like all these really sensitive things. But instead we have this basic description. We can read the phone state, which to most people says, like, was it the power state? Is it on or off? There's a whole a layer there that's not being abstracted. There's a whole, we're missing the whole point of taking the information and presenting it to the user in a way they can understand. Technology versus productivity. So vendor impersonation, this is a big issue which we'll talk about more. For example, I can go and create an app called Angry Birds 3 from Moscow Industries and put it up, and I'll get 5,000 downloads. There's no one there saying that you shouldn't be able to push Angry Birds 3. I shouldn't be able to be MSNBC2.com. There's no process there. So that's kind of the big things that's one of the things that plays in the rest of this presentation. As I said, malicious developers can masquerade as legitimate products, what I just talked about. John Oberheide provided a good example of this with his Rootstrap example. So Rootstrap, if you guys haven't seen this, basically it's a series it's an app that can pull down native payloads and exploit the kernel in Linux. John finds these things in his sleep. He's got a new kernel bug like every couple of months. So he created this example and made it themed on Twilight, the Twilight movie series and whatnot. And as soon as he installed it, people started downloading it and using it, right? So it goes in this whole thing I talked about as far as the idea of getting people to open things has changed. They will open them. They're consumers, right? And you're pushing an app to 300 million people, not 1,000 people at a company in a spear phishing attack. So your odds change dramatically. The whole attack surface changes. So risks to Android users. We're going to talk about each category here, go into depth about the main risks that we found that are out there in the marketplace and for Android users using the phone. So malware. So this is a big thing. Everywhere in the press, you're going to hear about all the malware on the Android marketplace. There really isn't that much. I make a software product for antivirus. I'm shooting myself in the foot here, but I think it's better to be honest. There's maybe a few dozen main categories, and those the variants. There's a few hundred. That's all that's there. But that being said, third-party markets are a whole other story, right? When you get into China, China third-party markets, the rest of Asia, South America, it's a lot different. You see a lot more of these things. And also the sophistication of the malware. Back in the Windows era, when we saw these things, we get 10,000 a week now, new variants. But the advancement of the malware is much different than we saw in Windows. Well, over a period of several weeks, we've seen these basic malware candidates that just send SMS text messages for pay services to these things like I think it's Nickbot, maybe one example, where the payload will have GPS coordinates, and based on where you go, it'll record background audio, then fire it off over a covert channel with someone. This is where we're at now. Much different than we've seen in Windows. Not just grabbing some HTML file, maybe with some cache or some credentials or SSNs, some of those things. Trend Trojans are a new thing we're seeing too, and I talked about this with Angry Birds, where I can go upload an app called Spider-Man 4, and I'll get 10,000 downloads. So the people follow the trends. Like an election comes up, they make an election app, right? New movie comes out, there's a movie app, Iron Man 4 app. So everybody's riding these trends, and they're just pushing out malware, and people want that feature so bad that the normal process they go through to validate these things, they just want it so bad they install it. So you have this trend Trojan kind of thing going on that really impacts the security. Even people that, that are careful about it. So when installing apps is a series of steps you can take to help better protect yourself. I think the most important thing is it's common sense, but still, those are things that you think about. The longevity of the app, right? Like it hasn't been around for 9 days. 9 days is kind of the ballpark that we see where people, we got these guys that are looking at malware, analyzing the market, what we call scraping, downloading the marketplace, analyzing apps. They usually find them in that ballpark, 60 to 90 days, and they find them, isolate them, give them a name, and it's malware. So if it's there for longer than that, then you're not safe, but you're in a better place than you were if it's there for a week, right? The ratings are always good too, but keep in mind ratings are like everything else, right? Where you can pay people and outsource it to go and fake ratings. Like look at Yelp, right? You have 1,000 postings. The guy with the same writing, right, where he's got like dash initial for every single comment. He's been paid to do that. So keep in mind that ratings are useful, but look at the diversity of the ratings. Keep in mind that if they're too similar, they can be faked. Anything else, but it's always it's a good factor. Developers. Is a developer Microsoft? Is a developer someone that you've installed software for that you trust? Is it Microsoft with a 0? Those kind of things, right? We've seen in certificate validation issues. The permissions are a big giveaway. I talked about this earlier where permissions give information, but they don't describe what the permission really entails, what you're going to get. So for example, I say like the Spider-Man 4 app I use frequently, it asks for privileges to receive SMS messages. Does a game really need to receive and look at your text messages? So it's a little bit of common sense there. These things should need no privilege besides maybe internet at that most to post stats about a game, or if you're in an office app, should have an internet access. If it's a telecommuting app, yeah, it makes sense to have those things. But a lot of these apps, like if you go online right now and search for weight loss or something pornographic or gambling or anything else, they'll ask for all the permissions. It's a dead giveaway, right? What you're getting into. So look for those things. Keep an eye on them. So the auto run thing it's kind of interesting. When you create an app, you can create receivers, like event handlers. So you see in a lot of computing platforms, where certain events will trigger an action. In this case, you can have one that maybe when an app's installed or someone changes a GUI from one UI element to another, and all these events, it'll kickstart your app. So even if you install it and you don't run it, it can still be running in the background. So this is kind of interesting because a lot of security apps, antivirus products, because of the framework of what we have, we can't scan the apps until they've been installed. The vendors and third parties, they don't give us access to stop the install. So there's all this like running behind the scenes that happens to try to make this, to kill processes, but there's still a window there where an app can be installed and run. So it's a pretty big issue. This is a bypass on most of the AV that's out there, right? Just currently, unless you're vendor bonded, which Winmo and WinPhone 7, there's nothing you can do for kernel drivers. You have anything there. Android's pretty tight about it. iPhone, same way. So keep in mind that the security that these products offer, we do offer some security, but there's these little caveats because of what the framework provides we can't overcome. Shooting myself in the foot again, but honestly here. So Wi-Fi hazards, which I'm sure everyone in this room is intimately familiar with. But some interesting caveats with the apps. Many apps don't encrypt wireless, don't encrypt traffic, right? You hear about the auth token issue maybe with a lot of the Google apps and services, where the auth token used to sign into all your services. That one token that you log into Gmail can be replayed to log into Google Docs or to anything else, which we'll talk about more later. So a lot of these services aren't encrypted. Now Google's now encrypting their apps, but you have this rush to market problem, right? Where, how many people are going to write an app? They go down to Barnes & Noble, they buy a book on Android apps for dummies. A month later, they have an app out. They're not going to go spend $5,000, $10,000 to have a security company audit their app. So these kind of things are a big deal. They're going to race to push it out, and we see these things, and not rarely. Almost every app we look at, we see these things. We're dealing with consumers making software, not 20-year veteran engineers making software. We're dealing with opportunists. So keep in mind also when the phone's off, in the background you're constantly seeking services. So if your phone's just sitting there, say you go to your favorite coffee shop, right, and you log on once, and you connect when you're in range. You walk in there tomorrow morning and you just installed 4 new apps, get a cup of coffee, but your phone just logged on. Now it's sending data over the wire, and you've got some guy sitting in the corner with an arrow dump or some sort of sniffer capturing your traffic. And if there's tokens there, then so this is a big issue. When you're auditing Android apps or mobile apps, the leak of privacy is a huge issue. Wall Street Journal did a study about this and found that the majority of apps leak information. Not some, not a few, but the majority. We're talking like 80% of the apps. And hackers can hijack your app accounts. FaceSniff, you guys maybe have used or seen. Interesting app that you can run on a wireless network like a public Wi-Fi, and you can hijack Facebook accounts. People that are working there. So recommendations: uncheck connect within range. Develop a behavior of connecting when you need to and connecting in. So when you're walking by all these places, your phone's just not connecting automatically and risking your phone to compromise. Only connect when you need to. And it's one of those tasks that seems mundane, but it makes a difference, right? Any auto-connect functionality, which is enabled by default, auto-connect on insecure networks, these things, turn those off. App phishing, this is interesting. So rogue apps can masquerade as legitimate apps you trust, right? So the idea is that an app, when installed, will wait for an activity in the background, like wait for you to log into your bank, right? And then overlay a screen on top of the same log and everything else, which conveniently can be pulled out of disassembly and just pasted into your phishing app. So it behaves identically to the app you look at. There's no distinguishing marker, right? You can take the code and rebuild it as a new app. So think of like a clipjacking this whole thing with Flash that happened. Same thing for Android. So we have a demo here I'm going to show of app phishing. So here I'm going to go ahead and spawn Skype as an example. Sorry a few of those that I met last night that working on Skype and auditing. So we're going to log into, or attempt to log in this fictitious account that we have reserved, Private Tier Labs. We'll give it a moment, then it's going to fail. So this is the real Skype application, right? Okay. There's me fumbling, tired on an airplane, going back. So now we're going to install, I'm running ADB to install an app in the background to do the app phishing, to demonstrate that. So that's going to kick open. There's a quick flash, it's called AppJack. Now, I'm going to run Skype again. Same screen. I'm going to type in test. Slowly. Test again. I'm going to click sign in. Your password's test. Right? So you follow that? Does that make sense? So I created an app and I overlaid it, and then I closed it out. Now I've compromised the credentials. So, we just protect that. One, when you install an app, things like read logs or get tasks, those are used to get information about the system, like what processes are running. Most apps don't need that. In fact, few apps use. The only apps you really need to give privileges for are system utilities or security products. Games and your typical Office document kind of apps, all those things, you don't need any privileges for. They're basic apps. They open, they create documents, they save them. If they upload them to a website or you can share them, maybe internet's acceptable. But read logs and get tasks, there's really no reason for that in a normal app. A big kick, or a trigger you can see, is when you log into your normal app and all your credentials that are normally saved, if you save them, aren't there. Like in the previous example, the Private Tier Labs was not there. Right? They can't gain access to that sensitive data in the other compartmentalized product directory. So those things aren't there. It's kind of a visual cue to help you kind of trigger something that you may have an app phishing thing, especially if you just installed Spider-Man 4. Right? Keep that in mind. So rootkits are somewhat new. We haven't seen a lot of them. There's proof of concept over at DEF CON 8. There's an Android rootkit these guys wrote, Spider Labs, that it works. And there's this whole kind of theory that rootkits and all these phone platforms and hardware, it's not going to work. It's all ARM. Okay, you can write an ARM 5. It'll work in anything. Okay, if you don't have symbols, you can still fingerprint the syscall table based on basic antivirus techniques we've done 15 years ago. You can find the table. You can put your pointers in. Rootkits are beyond plausible, but the thing is that the people that are writing this stuff aren't putting it on the market. So what we've seen privately from our incident response wing, the only time we've seen these are part of zero-day attacks. Someone has a threat, like an SMS or an image bug or something, and they launch that, and that'll trigger an install for a rootkit. Only time these things are, they're very rare. Also, apps that utilize Jailbreak can also install rootkits, obviously. You have to have root to install a rootkit. All right, makes sense. Yeah, this is my angry slide. There's not a whole lot you can really do about rootkits. Because of the framework, you can't get in the kernel. Right? So once they're there, it's the whole, the whole Zen proverb, the whole tree in the forest kind of thing. Rootkit's there, you're not going to find it. Right? You can query all you want. If it's a good rootkit, you're not going to see it. So this is obviously an issue. Luckily, we haven't seen a lot of these attacking the marketplace. They're targeted attacks, company to company, government to government kind of thing. So botnets are really interesting as far as a mobile platform. We've seen a few frameworks circulating around. that allow a botnet kind of service, command and control channels like we've seen in malware. And I give an example here where all the features of a mobile phone you can use, where you can record video, right? Someone's talking on a phone and they're walking around. You have video snapshots, the room they're in, and the audio. So you have face print, voice print analysis, you have the location. The wealth of information that can be used with this is staggering. So that's why I say the mobile echelon. If you guys are familiar with echelon. These resources will be tapped at some point, if they're not already tapped. Protecting yourself, same kind of thing. As much as we can offer is be careful what apps you install. At the same time, there's not a whole lot you can do. If you have guys that can write a mobile botnet and do these kind of things, the best thing you can do is just not install apps that you don't trust. Be careful about it. And there's some more preventive measures we'll talk about related. The physical boundaries thing is really interesting. So mobile platforms are obviously mobile. So if I compromise a phone of someone in the audience, for example, then when you walk by Starbucks outside or a coffee shop that you've signed into, now I can attack that. And you go home, now I'm attacking your home network. Then you go to work, now I'm attacking that. So when you have a botnet of a laptop, it's interesting. But when you have a mobile phone, all these nodes move around constantly, different networks. So it's much more powerful. It's very alluring to attackers. So we haven't seen a lot of these, but they will come. When people realize how valuable that is, it's going to get interesting. It goes back to my same premise. I talked about previously, don't auto-enable, auto-connect. Hackers don't deal with security products. They don't write exploits to get around security products. They write proof of concepts. So if you have another layer there, usually that'll stop it. We talk about that here. Sort of a firewall app, for example, exercise college when installing apps, disable auto range. There's an app called Anti, written by this guy Itz that I talked to. It's kind of cool. It's a Metasploit app for Android. So you can run Metasploit from your Android, the network you're on. All these things are kind of popping up there. A lot of them are foreign technologies. They're really neat stuff. Jailbreaking is and I hate to be, my phone's jailbroken. All the phones in our lab we use. But when you jailbreak a phone, the technologies that do the escalation of the transition from basic privilege to root are complete garbage. Complete, utter garbage. There's no security developed in mind. The whole point is to get your root. For example, the idea when you trust an escalation, you trust the parent process associated with the child process. So say Acme app runs bash or some shell. So you trust Acme to run bash. But these popular jailbreaking packages just trust bash. And then it's default to remember. So when you install it and you use it, now you're trusting the shell. So any future app can just run SU from a shell and have root. So when you jailbreak a phone, keep that in mind. And the majority of users trust bash. As I said, you can just invoke SU. Don't jailbreak your phone to have a better solution. It's not a thing for consumers. If you're a security expert, you know what you're doing, you can do it. But keep that in mind, that you're opening yourself up, that any app can use that. And they do. Most malware now will check for that. They'll SU and look for a pound sign. So keep that in mind. Second thing, like when asked to approve an app for escalation, uncheck the, like super user APK, for example, on Android, uncheck the remember box each time. So it's every time you get asked, you can allow it for that instance. So that'll counteract the whole problem there too as well. So hacking Android. Tools. Dex-a-jar. Take a dex, which is the compiled compiled code, convert it to a jar you can decompile into Java source. APK tool is a great tool. You can disassemble into the language they call it Smalley. It's basically built off Jasmine. So it's a textual representation of the assembly that you can use. Cool thing about APK tool is you can change things in the app and rebuild it, which we'll talk about the benefits later. Dead's actually a pretty cool decompile these guys wrote at PSU. And allows you, it decompiles the code, but it's much cleaner. They go through and remove a lot of redundancy and class. All the optimization that happens, they remove that out and clean up the code. So it's much better to read. If you use Dex-a-jar, your code's not reliable. The guys that wrote that haven't updated it in eons. So all the complex loops, recursive logic, all those things will get dropped. Exception handlers get dropped. So Dead's pretty good. It takes a little bit of time to set up, but it's much more reliable. So Source Insight is probably one of my favorite tools as an auditor. If you guys use Source Insight. All the highlighting information, you can load your entire source base into it, all your Smalley from decompiling. We created a custom template for Smalley and Jasmine. So we have the highlighting from the methods and all those things we can see. And you can do cross-references. You can go from language to language to language. It's really neat. The binary editor, 010 editor. Really popping the antivirus scene. You can create templates as well for certain file formats. So you can walk all the structures and change things and automatically fix checksums and all this stuff. It's pretty cool. And of course, IDA. Everybody uses IDA, reverse engineering. If you're looking at native code, you have to have a good tool. It's pretty much the de facto standard. Okay. Building Android source. So this is pretty much a nightmare right now. I've spent a year neck deep in Android, and I want to build some sorts of tests on the findings this last month. To get it working is a nightmare, especially when kernel.org got hacked. You're getting it from these random locations. So if you're going to build it, start with Ubuntu 64-bit. They're going to tell you that 32-bit works, but you're going to end up making 100 changes to your files to make it work. Just get 64-bit and use that. And then pre-built binaries, there's a lot of good ones out there, you know, as a list here. GDB server, TCP dump, on and on. They're useful to have. They're already pre-built, so you can just push them to your phone and use them. Okay, so the auditing process, things to look for. Now we get into the really fun stuff. Starting to talk about the security holes we found and things we've seen in Android. We'll go through each individually. So permissions, as I talked about, as far as malware. Now when you're auditing, it gives you an interesting, you know, there's a thing called attack surface area, ASA. When you look at the technology, you want to get all the ways the input can come into it. That's where you start your testing. You work your way to the core, and you have like the down, up, top, down kind of strategies, but it'll get you around the entry points, the most important part of an application, the part that a remote attacker can touch, right? So in these cases, like read logs, we have an example. You know, if it's reading logs, can I write to a log and cause a problem? Internet, meaning it's maybe a leak for information, or there's a Webview or some browser that's being used, and receive SMS, which is like the holy grail for bug finding. Meaning if there's a bug in that, I can send a text message to anyone here and compromise their Android phone, right? So receive SMS is one of those ones I keep using. It's a really nasty permission. So for example, Norton Security, the latest version, they have a buddy system for their anti-theft where I can assign a buddy with a phone number. And they can locate my phone if I lose it. And it's trusted to their phone number. Unfortunately, this feature never worked, apparently. I don't know if anybody ever tested it. They send it from a different phone number, and that doesn't check the number. In fact, the code is not there to check the number. It just skips over it. So I don't know where things got disconnected there, but but you also have a password, right? That that you have to use to supply these commands. But the password, there's no strength guidelines. So in my test that I found with our census group, people chose like P or password. We're not security professionals here. These are consumers. Okay, so the bar is different. We have to remember that. And of course, even if you have an SMS, even if this feature did work, you can spoof text messages. I mean, it's been happening for a very long time. Like since there were text messages, you can spoof them. So yeah, buddy verification is broken. Password guideline strength doesn't exist. And there's no limit for authorization failures. And they're not shown to the user. So I can send 10,000 text messages to you. With every password I can possibly think of. And you're never going to know about it. I'll know when I get a response saying location is 10 meters from you. Or where you're at. So it's a combination of critical point failures. Security in layers. When you're a part of a security company, is how to develop a solution. When each layer is broken and you have 4 or 5 of them, it's not a good thing. All right? I will probably not be doing any work for Symantec after this. Activity reuse. So this is pretty exciting. So if you think back to Windows and actually the Windows environment's good. It's a good candidate. Where you have RPC services. When you call a service, that service can impersonate the caller. So it acts on their behalf of their privileges. And technology has been around for 14 years. But in Android, when you call an app's activity, like I call, like say a feature in some app, like Twitter, I want to send a tweet, it's being run as Twitter. There's no impersonated. So keep that in mind. You can call all these different pieces of the application, and it'll run as that app. That's a good attack surface to look at. And we talk about how to find these. We have free tools. I'll provide an email address if you guys are curious. We wrote some scanning tools that'll scan for apps that export activities, those kind of things. They're open to the community. So we looked at 618 apps. We actually looked at 10,000, but this is the earlier report. And out of those, 3,592 were activities. This is the results of the ones that were exported without checking privileges. So almost all. We go back to the same thing. It's consumers writing software, right? It's not necessarily their job to make software secure. There's no one telling them to make software secure. They want to get in on the whole this cool mobile thing that's happening and push out apps. You can't blame them, right? So reusing activities is a pretty big deal. I reported this earlier this year in Skype. If you see here, you create an intent. Think about like an RPC packet or Corb or anything else where I have a packet I'm firing out to a process like an IPC packet. And you provide data that you attach to it in a sealable envelope. Here I have the basically like variables that are parsed in, the call target, the type, the phone number, right? Then I start the activity remotely, and I'm making a phone call with Skype to any phone number that I choose. So your pay-for-use kind of things are obviously an issue here with malware. SQL injection. So Android's vulnerable to SQL injection, right? Which we could have guessed. Anything that uses SQL is probably vulnerable to SQL injection. Now I'm like rediscovering the wheel here for like the 4th time in my career. But one thing that's interesting about this, the reason I mention this, is that developers are new to software. Again, if you see I'm pushing a point here about consumers being new to software, a lot of them don't understand SQL. Don't want to deal with prepared statements. So they write a quick SQL query, they copy and paste from, Code Project or some site that works for querying a simple database. But now they have string-based queries. So they're vulnerable to SQL injection. And most of the products use string-based queries. Not a few, but most. As I mentioned, it's preferred by new developers versus the SQLite. What am I doing here? I think I got my slides out of order. Look, XML injection. So we're moving on to this. This is preferred versus SQL. XML is simpler. The framework's easy to use. They have things like shared preferences, all the stuff they can use. Of course, they don't sanitize them for XML. I mean, someone who's new to writing software, they're not going to get XML injection is the bottom corner of security. Right? It's one of those niche attack classes that we learn over time, but it's rarely applicable, but it's important. So of course, new developers don't know about this. I actually found this in my app that I wrote. That's the reason I talk about it. We all make mistakes. I had a trust app thing in my product that I wrote, and I would take the app name, right, and I'd put it in an XML file. But you actually can have, I'll go here and skip through a couple here. You can have any value you want in the version name of these fields. So you can create your own blob in the middle of them. So I contacted Google about this, and I got a response saying there was no vulnerabilities in the Google platform. Then they released a new SDK where every field is being validated now. So I think there's an issue there, just potentially. Also, while this stops you from adding these malicious tags or things in using the Eclipse plugin, you can use anything else to add a field into a binary XML file. It's not voodoo. You just change your value in the hex editor. So these problems are prevalent. At the same time, they require people to use XML, and they're more vulnerable when people use their own raw XML. So you can search for things like like less than or left caret XML. I mean, they're building from strings, which typically the APIs will attempt to do some sort of validation, but if you're using pull or satchel, all these things, they don't. You have to encode them, and there's XML encoders all over the place to encode these things you can use. Package name trust. So this is a nightmare. This is really interesting. So think about like DNS name squatting, right? So I can go buy com.bing 2 through 100 or com.microsoft.bing, and I can buy it if I want to and put an app out. There's no validation. So it's kind of like DNS squatting where you have people buying these things. What makes it more interesting is that apps will trust these names. Furthermore, they'll trust a name for one app on one market, right? We have like advanced task code, which I'll talk about next slide here. They'll trust this Hero LED, which is the default LED driver that comes with some phones, Samsung and whatnot. They trust the package name. They won't show it in your process list, right? But when vendors install apps, they push it down from the mobile vendor. They don't buy a spot in the marketplace and push it out to subscribers. It's on the phones. They never actually buy the name of the package. So I went and bought the name of the package. There's an app right now you can go and download that's the name of the same package. And if you look at the task killer and all these process based like task managers, then you won't see my app. It's invisible because it's trusted, right? So this whole package concept's interesting. So squatting, I talk about that obviously. I could go right now and buy every variant of every Microsoft technology I could think of, right? And own those namespaces, like a domain name. And there's no terms of service violation or anything like that. Creates kind of a weird issue. That goes in the planning process. Now when you buy an app, you have to get that really quick. Like you're going to build a website, you buy the domain. I have to get that package. So, and keep in mind when you get a package on one market and a product trusts it, you have another 24 markets. You also need to go buy that package name on. Because the app will be used on that market as well when people travel or they use multiple markets. Webview traversal. So The model's changed on mobile phones. When you think of cross-site scripting and those things you hit in the browser, mobile phones place the web browser uniquely in their own apps. When you use Facebook or Twitter, all these things, you're not using the Android browser, you're using a Webview inside that app. So the context of those of you that are web auditors and web security, you have the same origin policy and all those things. There's a different compartment for those. So if I attack the browser and for Facebook, no one's ever used it or logged in. I can't get a cookie or use SQL injection or cross-site scripting kind of thing. But there's a way to reach out and enact these remote web views. There's features like the browsable interface. You have, those who are familiar with Windows, there's the URL monikers, or protocol handlers, they call them. Where you have like, gopher, // or FTP, // or all these things. So they create their own handlers. Like say I had one called HTTPX. When I click that in a browser, that'll invoke the app, right, that uses that. And if I have a cross-site scripting bug, now I can exploit the apps too. So now cross-site scripting bugs are big on browsers, but now I can push them to all mobile phones as well. And now it can also be exploited in apps. And also CSRF is an example. I have one here where I can add script or I can add whatever else I want that'll be replayed through the web view to the target site using the authentication credentials that assigned in app. And apps automatically log in and sign up when they're started. So you don't lose that window anymore. When you're attacking cross-site scripting of an app running in the background, you have a small time frame, right, where it'll run, and you hope you're going to get that cookie and get access to it. Apps are there all the time. So as long as someone clicks that app at some point at all on a mobile phone, so it changes the attack surface with web security. Checking my time there. Okay, InfoWeeks, we talked about this. I tried everything. Those of you that want a man-in-the-middle setup, I tried it all. There's a lot of solutions. For me, I just got in Ubuntu 64-bit, PPTPD, IP tables, report and redirect through a burp proxy. That's all that really worked. I tried everything. Malware works in some cases, but it's more or less an iPhone solution. This works for everything. If you guys want rules for that or a setup, I have it. Send me an email to my email address. Happy to provide the whole setup for you. I burned an entire week on this. It's embarrassing to admit just so I could see traffic. Those things you hate doing, right? So attack surfaces. So the browser attack surface is great. All the code's written in native. All this stuff is open source Linux libraries. So you can just do a search, I call it like changelog hacking. It's really funny, right? Go after a big product you want to exploit. You can just look at their change logs for the last build. Look at the bugs they fixed. Let them do the work for you, ironically. It's all open source. There's benefits and there's also dangers. So moving on. So some cool tricks. A lot of Android apps have this isloggable feature where they check the log level. And the Android app builders will, if it's debugged, they'll write everything out. So you can set those log levels in the shell and make it all verbose. Now, for example, I did this with Twitter, and every single operation Twitter is written out to the debug log when you're testing. It's a nice little trick to auditing apps. Turn on all the debugging as if it was a debug engineering build. Instrumentation, this is pretty cool as well. So you can use APK tool, and you can decompile an app, and you can re-engineer your own code in. So say you're doing a man-in-the-middle attack on the marketplace app, but it's going to fail in SSL cert validation, so you can't see the middle of the traffic. But you can build in your own code to automatically accept certs. You override certain methods in Java. So you can instrument all sorts of cool stuff, fuzzing frameworks, you name it. Your own code auditing, dynamic analysis, but you can build it in and then recompile. It's a really interesting way because Java allows us to do that. You can do that in C, playing around with Python and all these languages and the hooking libraries do these things. In Java, it's so much more simplistic. You can rewrite the entire thing and add your attack surface or your attack kit into the app and just have it run and audit itself. Okay, Android, now we're going to security hole. So we're all past the song and dance of me spieling about Android and the random crap that I came up with. This is what the presentation is pretty much about, so I'll be honest. The reason you're here, see all the cool security holes we found. So liblog, the logging service in Android. The path /dev/log, all the devices are role writable. I can arbitrarily write logs. Logcat uses liblog. So is anything else parsing logs? Logcat has a lot of security holes in it. Several dozen heap overflows, right? So any app that uses Logcat, like pretty much every antivirus product, is vulnerable to a heap overflow because it's running in the context of the app. Also, anything else that uses Logcat, for example. Now logs can also be written remotely. Say like when you start a browser, you print out the URL. Can I encode things there and trigger the same issue? The bugs that we found are in the same exact location as I reported previously. And what we're going to disclose more details once we've kind of got the okay from the rest of the vendors that are affected by this, or maybe the following week. That's a nightmare. I mean, when you get deep down into what I call intern code, right? The core security features are written by the veterans. Then you have all the extra stuff you got to just rush to mark and get done. You have the intern code. This is intern code, definitely. Probably pissing somebody off that hears that, but it is. I mean, it's all basic 1995 security holes. String copy, string cat, no link checking, things that any modern compiler will throw warnings off left and right. If you build code, you don't have warnings. It's not hard to fix, right? It's about being a good developer. So tombstones, this is the Android developer-friendly version of a core dump. They're textual representations of a fault. Here, for example, if you see this when you're auditing Android software, what that indicates in Android internally when there's a heap failure, a corruption, you're not going to get a failure to access a forward or a backlink, right? With heaps all coalesce blocks. And when they move it or coalesce to these things, you'll see these errors in forward and backlinks. In Android, as soon as they do one of these checks, they'll throw in a abort, which will throw a pointer read error on dead bad. So when you see that, you hit something pretty good. That means you hit a heap corruption or some issue, right? SQL injection. So it's a problem. It's also a problem in the Android framework. Okay, SQL query builder internally does string concatenation for everything. You think you're building safer queries. It's all string concatenation in the end. And furthermore, the query and managed query APIs, which are used by pretty much everything out there, content providers, all this stuff use these. They have these arguments for where and order by. We can do a where, X equals this or X equals this, vice versa. Those are using internally a query builder. So you can put in your entire SQL query and delimit it. Now you have SQL injection and safe SQL APIs. Mobile vendor issues. So just in case, and Travis Eckhart recently just talked about this, HTC wrote an app to go out and gather all this information, right, about mobile platforms, or about the apps running on the machine, the account access from Google, all these services, email addresses, phone numbers, all this stuff, and they store it locally, but then it's world readable. So it's the same thing with vendors. I call it crapware. It's been called crapware. You go buy a new laptop and you have 40 tray icons. It's a vendor negotiation. Now vendors are changing their stance to where they're saying, like Microsoft, for example, has gone and said, hey, we'll give you support for your new Motorola drivers or Samsung, but we don't want this crap installed. Your software will work better. We're going to have default driver support. So that's changing, but now it's back in mobile again. If you buy a phone, you have all these annoying apps you can't install that Verizon people will put in. You have Blockbuster. I don't care about Blockbuster. If you can't remove it, it's there. Every time you open it up, you have these apps. So we're back to crapware, but now we're on the mobile phone. And these things are likely vulnerable too. Then what? You can't uninstall it. What do? They force software on your phone you can't remove. It's vulnerable, potentially. Or at the least obnoxious, right? Excuse me. So Motorola Blur, their framework, their updates are over OAuth. They're all unencrypted. So have fun with that, I guess. Just want to sniff around an Android phone or an iPhone, install some apps. So much is unencrypted. Cookies and session IDs, all these things are unencrypted. Goes back to the whole thing. So again, the holy grail of mobile phone exploits. Probably my favorite part of this whole thing, right? My big slap in the face, all the reporters that gave us a bunch of grief. Remote app installs, right? To be able to reach out, pick a phone number, and I can install an app on a phone, right? All in stealth. That's what the good stuff is. Also, the most serious of the threats. So I have an example here. So Google account linking. So another one of my obnoxious videos. So Chrome, default VM, nothing else installed. I'm going to go and open up and clear all the data. Notice the beginning of time. Everything's cleared, no session information whatsoever. Now I'm going to go log into some random Google services here. I'm going to log into Docs, right, from my dummy account. Oh, this kills me every time I see it. It's good stuff. Close your eyes. Okay, now we're in Docs. We're logged in. Now, we're going to go to the marketplace in Android. So watch what happens. This is interesting. Those of you who are familiar with Google will probably can predict what's going to happen. Those of you who are not will probably be fairly concerned. I'm going to click Sign In. I'm just signed in to my this mobile account now. And now I'm going to go and install an app on a phone. So if you think about that, what does that mean? That means that any one of these Google services, if they have one cross-site scripting bug or one problem, you can compromise that, not only take over every Google account, but also install an app on the phone. Right? That's a pretty big attack surface. I'll be getting angry phone calls about that later, I'm sure. So I know what you're thinking, right? They're pretty good about hardening their services. Cookies are HTTP only and secure. You can't check them. But unfortunately, you have things like certicom bugs, right? There could be a null certificate, and now everything's validated. So I say you're one null byte away from having your phone rooted. Thanks for certificate validation. We have to worry about it. On my way here, I was in San Francisco, and I got on my phone. And I, hypothetically set up an example where I may have manned the middle, hypothetically speaking, to go and pose as a Gmail service, right? And I walk up to Starbucks and I say, I keep getting certificate warnings about the domain name doesn't match the target or something. What should I do? He's like, oh, we get those all the time. Just click continue. Okay. Same thing in my second airport, which I won't name because they're a little bit more ruthless. Walked up to a place where I bought a cup of coffee and seafood at the same place, which kind of threw me off. I asked her, and that's the woman there. She's like, I don't know. She's like, I would just click continue. I go back to the consumer issue, right? There's all these crazy attacks on man-in-the-middle SSL. But to be honest, it's 3 clicks away. The consumer wants to check their email. They're on the way to work. Not security professionals. That's the whole thing I'm trying to push here. Is it's not targeting security people. We're targeting consumers. Okay, there's a whole different thought process here. Our loved ones, the people we know that don't have any idea what's going on, they want to use their stuff, right? They want to click their button and use their stuff. That's what they want. So, hypothetically speaking, I may have written an app that I deployed using a hypothetical proxy in burp in an airport somewhere in the world. And then the app may have sent this and said, I wish your vendor would validate the security of apps before providing them to you. There was a man for that. Of course, Steve Jobs. Okay, conclusion. Exercise caution when installing apps. Avoid free Wi-Fi at all costs. Laptops, the software is more up to date. You're not going to have clear text communications as much. We've written those guys for ages about that. But mobile software is different. I keep going back to the same thing. Consumer developed software for consumers. Okay. Consider installing it's not a shameless plug. It's actually a good idea. Install a mobile security app of some sort. At least to validate some of these things. I mean, maybe we only have a handful of malware on the U.S. market, but when you get into Asia, it's different out here. There's a lot more malware, a lot more people trying to make a fast buck. So it's good to have at least do a basic MD5 check to look at these apps. It doesn't hurt. Think about antivirus. With junior security professionals, they complain about how something doesn't work, how worthless it is. But if it solves a chunk of the problem, it's got value. It's a pessimistic view, right? If it gives you 30% more protection and it's free, then why not use it? To be honest. Again, consumers don't have the budget to hire security professionals. They only bill out $100 an hour, $200 an hour, $250, $300, God knows how much. A guy writing his first app is not going to spend $5,000 or $10,000 on his app. It's not going to happen. He wants to get out there and get it published. And marketplace operators don't currently perform vulnerability scans. Apple does. That's why my little plug for Steve Jobs there. They actually perform validation. I'm not a big Apple person, but when it comes to the way they develop the marketplace, they did it the right way. I can only theorize the reason that the Android marketplace is done the way it is to catch up in app count. They pull out all the bottlenecks. And I think once they get to where they're neck and neck, you might see some more features there where you can validate these things. Only thing I can figure out, because I know a lot of the guys in those teams are brilliant guys over Google. And if they wanted to, they could lock this down. There's got to be a reason. I can't figure out what it is. Questions and comments? That's fantastic.
Looks like they'll address questions to you face-to-face in person.
That's even better. I'm tired and I was terrified of everybody asking all these complicated questions I couldn't answer right now. All right, we can find me. I'll be dingling around somewhere, half awake. Well, hey, thank you for attending. I appreciate it. If you have any questions, I'll be around.